Okay, guys, quick little intro to what we've done so far in grade 11 college math over at Beal. Mr. Lupo's here, first video for this course. We're about a week and a half in, and we're dealing with quadratic relationships. So quadratic relationships are the ones that make parabolas. So we know parabolas look like this or like this. They either open up or they open down. So a quick review on this thing. Here's your parabola. You have a parabola with a vertex. So the low point or the high point, depending on which way it's opening, is called the vertex. There's symmetry involved here, so we'll get more to that in a second. But what happens on this side happens here. So if I was to fold this parabola over on itself, it would lay on itself. So this arm would go here. This is called a min. If it opens up, it has what we call a minimum because it goes as low as possible. And if it opens down, it has what we call a maximum. Through the middle here, if that was the middle, pretend that was the middle, is the axis of symmetry. The vertex has a point HK. So the maximum or the minimum is at K, and the axis of symmetry is the line X equals H. So this is how far left or right I go. This is far up or down I go to get the vertex. So if I was to draw this from scratch and I had a vertex over here, I would know that I go over a certain amount. So I go over H, and then I go up K to draw the vertex. So let's pretend we're opening down here. You would have a minimum of K, and the minimum takes place at H. So whatever this is, so if this is, let's say, 2 and this was 5, you'd have a maximum of 5 at X equals 2. The axis of symmetry in this case would be X equals 2. That's the equation of the line, and the vertex itself would be 2, 5. So that's a quick intro to parabolas. Over here, I got some more stuff. Let's switch my color up to red. You know it's a quadratic, or if you have y equals x squared, in your equation. So you have y equals something, 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 and x squared is in that equation. A lot of times we have this version here. This is standard form. In this part of the course, we're more concerned with this here, which is called vertex form. So what I said before, the vertex is HK from here. And we'll talk about that in a second. Parabolas have second differences in the table of values that are the same. So if I have a table of values, I get first differences. That's the difference of these points. And then if I get the difference of the differences, those will be the same if I have a parabola. So more of what we're looking at today was this, and I'll rewrite what I just had here. That's a minus. So y equals a bracket x minus h all squared k. So from here, we note a bunch of things. We have HK and we have A. So when I throw numbers in here, I'll just put some numbers randomly in here. That's a 7 squared, and we'll go plus 1. Okay, so I look at this whole thing, and this is my A, this is my H, and this is my K. All right, and what happens, why these are important is they really tell me everything I have to know about my parabola. First of all, H and K, so this is H, and that's K, and that's A. H and K will get you the vertex. Okay, so real simple. What you have to do, and this is a bit annoying, but it's part of parabolas. You need to change the sign of this number here of what looks like an H. Okay, because the negative is already built into the equation. So when you have a negative in here, you have to change this sign so that H, if it's negative, is positive 7. Okay, so negative becomes positive, positive becomes negative. Just get used to doing that. For the K, you do not. So my vertex is 7, 1. So if I had another parabola, it looked like this. Okay, 8. And I said, what's the vertex? Change the sign, leave the sign. Vertex 3, 8. What's in the bracket? What's out of the bracket? If it was this, what's my vertex? Change the sign, leave the sign. Okay, that becomes -1. That stays -16. Okay, so my vertex is -1 and -16 in this case. Where it gets a little confusing is when you have things like this, okay? And you look inside here and you go, whoa, hold on a second. This isn't the same as what I have up here. Well, it is kind of. It's really this. Okay, it's the same as that. So if you don't see a bracket, assume that your H is 0, and then your K is whatever 0. Okay, so 0, 3. Also, you might have this, x minus 9 all squared, just like that. Y equals x minus 9 all squared. So now change what's in the bracket, plus 9. And then there's nothing outside the bracket, so it's 0. So my vertex 9, 0. Okay, so that's all that. So go through, let's just do a bunch more. Y equals x plus 2 squared minus 1, x minus 6 squared plus 5, x plus 3 squared minus 10. Okay, so what's my vertex? Change the, oh, let's do some more. X squared minus 1, x minus 5, all squared. Okay, equals. So these are all different. Okay, so what's up? What's up with this? What's my vertex? Change the sign, leave the sign. Okay, so if I was to plot this now, let's just pretend we're plotting this. Minus 2 minus 1 means go left 2, down 1, and then draw your parabola. Okay, and we'll worry about how it's drawn after, but just worry about the vertex right now. Okay, what's my vertex on this thing? Change the sign, 6, leave the sign, 5. So how do I get this? How do I plot this? Go over, right 6, up 5. So we start seeing things like this. We talk about how this has been moved. Just tell me what the vertex is. If the vertex 6, 5, then to get to the vertex, you have to go right 6, up 5. What about this one? Minus 3, minus 10. So change the sign, leave the sign. Minus 3, minus 10. So I'm down here somewhere. So what's happening here? I've gone left 3, down 10. Left 3, down 10. Minus 3, minus 10. Here, nothing in the bracket, so 0. Outside of the bracket, minus 1. So there's my vertex. 0, negative 1. Okay, and then from there. And here, last one, x minus 5 all squared. Change the sign, plus 5, or just 5. You don't need to put the plus 5. And then what's outside the bracket? Nothing. But that's why, but we still have to put something here. So it's really plus 0, and you put the 0 here. So that's 5, 0. So that would actually rest there. Okay, so that's how you do that. Now, one extra thing, we're going to throw this in here, is the number in front of the whole equation. Okay, so ignore this for a second, the negative 2. Let's do plus 2. I have this, and I get my vertex. My vertex is 3, 9. No, it's not. It's 3 minus 9. Okay, and that's a minus. So 3. So how do I sketch this? Sorry, how do I sketch this? Go over 3, down 9. Okay, now this is going to give me a bunch of information. It's going to give me the step pattern eventually, but let's just look at this right now. First of all, there's probably normal parabola opens up. Y equals x squared opens up. If this number, which is a, is negative, then I flip it. I reflect it in the x-axis. So anything like this, x squared minus 2x, whatever, doesn't matter. If this whole story starts with a negative, okay, this whole equation, whatever it is, starts with a negative, that means I flip it. I reflect it. Okay, I don't care about if I moved it or whatever. This H and K tells me if I've moved it. Okay, so move it, reflect it, move it, stretch it, compress. There's 4 things you can do. Okay, so the first thing is it upside down? Does it open this way or does it open this way? This is normal. Well, that's not normal at all, but this is normal, and this is reflected. If it starts with a negative, it's reflected. If it starts with a positive, or you don't see anything, it's assumed it's positive, it's just straight like this. Okay, so it opens this way, opens that way. Okay, so if I have this, put an 8 there, plus 5, okay, my vertex, let's look at this. This says open down, it's negative, okay? This says my vertex is 8, 5, which is great. But this, we got one more thing. We got to figure out if it's stretched or compressed. And it works this way. Forget about the sign. Look at this number here. If it's between 0 and 1, which usually is a decimal, things like 0.3, 0.7, but sometimes a fraction like a half, okay? If that's the case, then we have something called, it's vertically compressed, VC, okay? And it's vertically compressed by this. And that means when we look at the step pattern, which we'll look at later, the step pattern is a little bit slower, and you get something that is wider, okay? Remember I was talking about a rabbit, pulling a rabbit, swishing its ears down? A small number will have a vertically compressed parabola. So instead of having a parabola like this, you have a parabola like this, or like this, okay? Squished down. If the number here is big, like in this case, my 3, you have something called, it's vertically stretched, and that's if it's greater than 1. So if A is greater than 1, forget about the sign again, just the size of the number, then you have something that's vertically stretched. And if it's stretched, it's skinny, okay? It's pulled up. Grab a rabbit, okay? Here's your rabbit ears. Here's your rabbit jumping around here, obviously. There's your rabbit, okay? And you take its ears and you pull it up, okay, by the ears, and it stretches it out, okay? And that's if it's a big number. So if A is greater than 1, then you do that. What happens if it's negative? You flip the rabbit upside down, but that's cruel, so let's not even think about that, okay? So let's look at these now. Let's look at all this now. Let's put it all together. I have 2x plus 5 all squared minus 9, okay? Forget, let's start off with this. This number here, is it positive or negative? It's positive, so it opens up, okay? It's going to open up. Now, where is the vertex? The vertex is from this and this. Change the sign, leave the sign. Minus 5, minus 9. That's my vertex, and this number is bigger than 1, so it's vertically stretched by 2, and there's your vertex. Okay, let's keep going. Minus 3, x minus 1 squared plus 5. Give me the vertex. Change the sign, leave the sign. Okay, there we go. Plus 1 plus 5, or just 1, 5. What's going on here? I got a negative, so it opens down. It's a big number, so it's vertically stretched. So it's vertically stretched by 3, and it's also reflected in the x-axis. Okay, if you get smaller numbers like this, y equals 0.2 bracket x, let's do this one, plus 3 squared. I'll put nothing here. First of all, what's the vertex? Change the sign. Nothing outside. It's a 0. Just leave it like that. Now, is it flipped? Does it open up, or does it open down? It's not flipped because it's not negative, so it opens up. If it opens up, if it's positive, it opens up. And then you look at this. That's smaller than 1, so it's vertically compressed by 0.2. Okay? Check over your notes. We did a bunch of things like this. Let's just do a couple more from scratch here. I'm going to give you a second here. Tell me if it's stretched or compressed. Change that to 8. Keep putting the same numbers. I'm getting old. I forget things. I confuse myself. I get scared by things, you know? That's what happens when you get old. Take a look at these things, okay? Tell me what's going on. Vertex first, stretch, compress, and is it flipped? First one. I'll give you 15 seconds. Or just hit pause. Or listen to me as I hum. That's whistling, I guess. Okay, vertex. What is it? In green. 5, 8. Change the sign, leave the sign. Flipped? Yes. Look at A. Flipped? Yes. So it's going to open this way, and this number is bigger than 1, so it's vertically stretched by 2. Next guy, vertex. Change the sign, leave the sign. -2, 1. So if I was to plot this, -2, that means left 2, down 1. Is it flipped? No. Okay, it's not negative. It's small, but it's not negative. So it's going to open up like this, and this guy here, because it's less than 1, will be vertically compressed by 3. Good. Watch this video again. It's very good if you can't sleep at night. Sometimes people have told me that it helps them sleep. Enjoy this first video. Hopefully it went well, and see you in class tomorrow.